So today we're talking about compound inequalities. A compound inequality is a series of inequalities that are related to each other. In this case, it's more than one. We're never going to have more than three. Honestly, you're probably only going to have two. It's kind of what to expect. There are two basic categories of compound inequalities. There are joint inequalities and disjoint. A joint is usually associated with the word and. Disjoint is associated with or. A joint inequality looks something like this. We have our two endpoints. We have our open circles. Then they shade in between them. It could go on this way and this way forever, but the part we care about is the part in the middle. How many inequalities do we need to represent that? Sorry, how many cases of interval notation do we need to represent that? Well, we have two endpoints, so we could have endpoint 1 and endpoint 2, and we could have a single case of interval notation to connect them. Disjoint looks something like this. We have our two endpoints, same as before, but instead of shading towards each other, we shade away from each other. How many instances of interval notation do we need here? Well, we need one for this side and one for this side. So we need two. One other important thing to remember is that when you do this, you also have to include what's called the union between the two inequalities. So that's the big U, it stands for union. And basically it connects interval notation together. Let's try some problems really quick. Let's try x minus 1 is less than 3 and x minus 1 is more than negative 2. So we have an and, so we're going to expect a single case of interval notation. Let's go ahead and add 1. So we have x is less than 4 and add 1. So we get x is bigger than negative 1. So we're thinking of numbers that are smaller than 4 but bigger than negative 1. This is probably the only time I'm going to do it, but we can go ahead and draw out a number line for that. So we've got 4, negative 1. I always put 0 in these just in case. Notice we're looking for the numbers smaller than 4. We have an open circle on 4, shading this way, and an open circle negative 1, shading this way. So where do they overlap? The place in the middle. We could write that as a single case of interval notation as negative 1, 4. Notice I chose soft brackets because we don't have the or equal to part of the equation. Now let's try a similar problem. Let's go n over 6 is equal to 0. Not equal. We'll go less than or equal to 0. Or n over 7 is greater than 1. So let's go ahead and solve one of them. We multiply this side by 6, multiply this side by 6. We get n is less than or equal to 0. If we were to write that as interval notation, it would be negative infinity to 0. Because notice, we have our endpoint 0. We're looking for things smaller than 0, which means we're going to negative infinity. Always a soft bracket, but we're going to use a hard bracket around the 0 because it's included. Let's try the same thing over here. We multiply this side by 7, multiply this side by 7. We get n is bigger than 7. If we were to write that as interval notation, we'd get 7 to infinity. We use soft brackets because the 7 is not included. To finish out the problem, we have to connect them together. Another thing you might see is a problem where it's something like this. 0 is less than or equal to 2n plus 1, which is less than or equal to 9. If you see something like this, you're welcome to go ahead and split it up. Consider one part, 0 is less than or equal to 2n plus 1, and consider the other part. 2n plus 1 is less than or equal to 9. We'll go ahead and solve this problem out pretty quick. We subtract 1, divide by 2. So we get negative 1/2 is less than or equal to 0. And do the same thing over here, subtract 1, divide by 2. We get n is less than or equal to 4. So consider the notation. That should be an n. I made a mistake there. Notice we're looking for numbers that are bigger than negative 1/2 but smaller than 4. Well, it's probably going to look something very similar to our and problem over here. We're going to end up with negative 1/2 as our small endpoint and 4 as our big endpoint. And they're both included because they're or equal to. So we can go ahead and wrap it up. And there we go. There's our problem. Email me if you have any additional questions. You know how to find me.